We'll have a look at the questions. Okay, so this is us filled in a table for our LDR circuit. Now, a couple of patterns we want to look at. The first one is that the resistance of the resistor stays the same. It is a 1 kilo ohm resistor. It will always be a 1 kilo ohm resistor. No matter what you do to the LDR, it will still be a 1 kilo ohm resistor. So that still be 1 kilo ohm all the way down. Whatever number you've got should be constant. Now, whether you've read the scale wrong in your multimeter, that's one thing. Now, this one should be the same, obviously, because voltage supply doesn't change. And what we're interested in is these numbers here. These numbers here should all add up to 5. These pairs must all add up to 5, or roughly 5. If they don't add up exactly to 5, that's not a problem. They should all add up to 5. That means that whatever share of the voltage they has must add up to the voltage supply. You can never exceed the voltage supply. You can only add up the components to make it equal to the voltage supply. And finally, what we should see is this resistance here getting bigger. So this number here is bigger than this number here. And this is an increase of resistance. So what effect does the light level have on the LDR in terms of its resistance? That's the question. What effect does the light level have on the LDR in terms of its resistance? Scott.
Is it the brighter it is, the less resistance it is?
Okay, so the brighter it is, the lower the resistance. The darker it is, the higher the resistance. Okay, so what I'd like you to do now is I'd like you to answer a couple of questions on it in sentences. So here's our questions here. Right, so these are the questions. We'll answer these questions and then we'll run through the solutions to these questions. Okay? Right, so we've looked at the table and I just want to give you a note on what the effects changing the voltage has. So in a bright light situation, in bright light, okay, so copy this down please, just underneath your two questions.
Is this the third question?
Yep. In bright light, if you've got something ready like this, then don't have to copy it down if you manage to construct a decent answer. In bright light, the resistance of the LDR is low. So it takes a small share of the supply voltage. In low light levels, the resistance is high. It takes a large share. Liam. Of the supply voltage. Okay? Now we summarise all this in a little thing to remember, and it's called LURD, but I'm not going to give you that. I think you just need to remember this week. We just remember that if it's bright, then resistance is low. If it's dark, resistance is high. If I am resistant to do something and I don't really want to, okay, I have a high resistance to going out in the wet. Okay, so if your resistance is high, then you don't really want to do something, you're resisting doing it. So I always think about it in terms of, if it's really sunny, you're always quite happy to do things. If it's really dark and horrible, you don't really want to do anything. So if it's sunny, nice and bright, resistance is low. If it's dark and miserable, resistance is high. Okay, light, resistance is low, dark, resistance is high. That's the way I always remember it for an LDR. I'll try and remember these two statements here. That's going to give.